Hello, my name is Sean, and I'll be doing a tutorial on waste management. I'm pretty excited to do this one because, well, there are a little bit some confusion of rules and whatnot, but you know what? I'm going to clarify them. And plus, I'll probably put up a paint sketch to give an idea of how this works. So this module does require edge work, so we're going to grab that right now. We have 4 and 2. Not much indicators. I think I only saw one. That's an lit November Sierra Alpha. And 2 port plates, excuse me. A DVI, PS2, RCA, RJ. And then for the other one, we have an DVI, RJ, RCA. Serial number is Delta 61 Charlie Bravo 0. Alright, so we don't really need anything in the module, we just need the edge work. So, for the first part, we're actually going to try and get values for our paper, plastic, and metal. The first part's pretty easy. So through each one we're going to do each condition one by one and see which one's true. If it's true, we do the operation. However, if there's an unless statement, then we gotta follow that one. And if the unless statement is true, then the condition is false and we don't do the operation. So, starting with paper, is there an IND indicator? No. Is there an SND indicator? No. Is there a parallel port? No, they're basically DVI, PS2, RJ, and RCAs. Is there a Morse code related on the bomb? And you'll have a little asterisk. So, Morse code modules are following but not limited to color Morse, Morse Maze, Morse code, Morsematics, the new 2 modules, Morse War, and Simon Sends. So, we don't have any of these, it's just waste management by itself. Are there 0 batteries on the bomb? No, there's 4 batteries. Does the serial number contain any letters from Save My World? Let's see, there's a D, so yes, there is letters from Save My World, unless there are more than 2 constants in the serial number, which unfortunately all 3 letters are constants, so the operation is false. So the starting values for each one is 0 as false. So each one has a value of 0. So paper, unfortunately, has 0 values. Now we go to plastic. Is there a TRN indicator? No. Is there an FRK indicator? No. Is there an empty port plate? No. Is there an FRQ indicator? No. So for plastic, there's 0. And then we finally go to metal. Is there a Bob indicator? No. Is there an MSA indicator? No, we have an NSA. Is there a car indicator? No. Are there any duplicate ports? Yes, there are duplicate ports because we have 2 DVIs, 2 RJs, and 2 RCAs. Unless there's a DVID port present, so we can't add 153. So that's going to stay 0. Is there a SIG indicator? No. Is there a forget-me-not on the bomb? No. So, our values are at 0, which can be pretty common, usually uncommon, but it can happen. So, then we go to the final instructions. And what better way to show how the final instructions work than showing a little bit of paint? Shall we? Alright. So, I need shapes. Okay. We're going to grab that. We're going to select it. And we're going to copy it 7 times. Six and 7. And they're all going to be labeled 1. Oh, geez, that's large. Let's make it like 24-ish. Should be good. 24 is good. Okay, 1, 2, 3, 4, 5, 6, 7. And we'll get another shape. We'll have this big square. And we're going to label it the end. So, here's what I'm going to draw here. I need my line tool here. So I'm going to go like this. It's not going to be the best, but it will be. 3. Yeah, 3 is also this. 5. I think there's another skip somewhere. Let me just look at the rules real fast. Okay, yeah, there's a skip here. So, do this. Do that. 5, 6, 7, and end. Done. Alright, so this is how the last instructions work. So, if 1 is true, that's it. That's all the instructions you have to do. Otherwise, if it's false, oh geez. Let's get a nice pencil. Thicker than that. If it's false, we go to rule 2. If 2 is true, we go to 4. If 2 is false, we go to 3. If 3 is true, we don't do anything else. We stop there. If 3 is false, we go to 4. If 4 is true, we go to 6, and 4 is false, we go to 5. And it doesn't matter which way we go here, because it doesn't matter if it's true or false, because we're going to go to 6 anyway. Doesn't matter if it's true or false here, because we're going to go to 7, and after 7, you're done. So, this graph looks very complicated, but I'll tell you that this module works very similar to how laundry works. And remember how laundry works. There we go. So, let's look at the first rule. If the total sum of paper, plastic, and metal present is higher than 695, so that's the total sum of all the plastic, paper, and metal, it's higher than 695, recycle everything, do not progress to any other stages. So, what it means do not progress to any other stages, don't go to any of the other instructions. So, once you've basically got the answer of just recycle everything. After that, so 1 is false, so we're going to go to 2. Otherwise, if the amount of metal exceeds 200, recycle 3/4 of the metal, then waste the rest of the metal, go to rule 4. So if 2 is true, we go to 4. If 2 is false, we're just going to go right to 3, which it is false, so we're going to go to 3. Otherwise, if the amount of metal is lower than the amount of paper present, which is also false, recycle all the paper, allocate all the plastic to the leftovers, waste 1/4 of the metal, and recycle half of the leftovers. The other half of the leftovers are not used. Let me explain how this rule works. So, we're going to recycle all paper. So, paper recycled is everything. Then paper would set to 0. The plastic goes to leftovers. So there's actually a fourth one here, which is called leftovers, which gets a value of, well, I'll explain how leftovers work. And so go to all of it. So leftovers get the value of plastic. Then we would recycle, we would waste, let's see, metal, waste 1/4 of it. Then what happens to the 3/4 of metal? The 3/4 of metal gets added to the leftovers. So the leftovers is the plastic plus 3/4 of the metal. Anything that is not used is all goes to the leftovers. And then finally, we have the leftovers, which is we're going to recycle half of it. So recycle leftovers, and we're going to do half of it. The other half is not used, so just imagine the other half of it is absolutely not used. And so this is how it goes to it. We have paper recycle, all of it. The plastic leftovers, all of it, which means the leftovers is plastic plus we waste 1/4 of the metal, so the 3/4 of the metal gets added to the leftovers, and the recycle leftovers is basically we're going to recycle half of it, the rest of the half doesn't matter. And we're done. Now, why are we done here? Because we did an instruction with the paper, we did an instruction with plastic, we did an instruction with metal, and we did an instruction with the leftovers. So, all you have to do is an instruction with once with each value and you're done. So same thing with laundry. Once you change like the drying, that's all you have to do with the drying. You don't change it any further than that. Same thing here. Once you do an instruction with that type of recyclable, with that type of waste, then you don't do anything else with it. That's it. That's all the instructions you need. But continuing on, if the amount of plastic is less than 300 and greater than 100, which is false, recycle half of it and go to rule 6. Since it's false, we're going to go to rule 5. If the amount of plastic is less than 100 and greater than 10, waste all the plastic, which is still false, but we're going to go to 6. If the amount of paper is less than 65, waste 1/3 of the paper, unless instruction 4 was also true, then recycle all the paper. Well, there's no paper to waste or recycle, so that's going to be just that. And finally, the amount of leftovers. Since we haven't done anything with it, since we didn't really have much anything, leftovers is also 0, which is if leftovers are less than 300 and greater than 100, recycle them, otherwise waste them. So we would have wasted any leftovers if it's less than or equal to 100. If any value ends up with decimal, refer to only its integer part, which is a nice thing. So, for paper, plastic, metal, we don't recycle anything or waste anything. So, on the module itself, you get 4 of these Roman numerals, each one with 1, 5, 10, and 50. You have a waste button, which you would submit how much waste you would do in. The recycle button, which how much you would recycle. A reset button, which resets what you submitted so far. And then a green submit button. So, as the expert, I would say, okay, just keep pressing submit, because there's nothing to do. Because everything was valued was 0. There was nothing else to do. So, let's do this a bit faster. We'll get our values real fast. So, let's see. 4 and 3. Lit TRN. And 2 port plates? No, 1 port plate. What am I thinking? Port plate with an RCA. Serial number is RV1GT4. Or Romeo Victor 1, Golf Tango 4. Alright, continuing on. So, IND indicator? No. SND indicator? No. Parallel port? No. Morse code in the module? No. Are there 0 batteries in the bottom? No. Does the serial number contain any letters from Save My World? Yes, there's an R, but there are more than 2 constants in the serial number, which is everything but vowels. So far, paper starts at a 0, unfortunately. So let's go to plastic. Is there a TRN indicator? Yes, unless 1 strike has already been issued, and you'll see a 3 asterisk here. So The 3 asterisk is the bomb time and strikes are taken from the time of the first press of the submit button and is recalculated with every strike on the module. Alright, so that's good to know. So as soon as you press the first submit button, it takes kind of like a picture frame right there and say, okay, this is how much time is on the bond, this is how many strikes are issued and whatnot. Of course, we don't have any strikes, so we do the operation, which is add 91. So for plastic, we're going to add 91. FRK indicator, no. Empty port plate, no. FRQ indicator, no. So plastic stays at a 91. Then we have metal. Bob, no. MSA, no. Car, no. Duplicate ports, no. SIG, no. Forgive me not, no. So metal stays at a 0. Then we keep following the rules. Also, one other thing. At any time the bar on the right, which is this thing right here, becomes empty after completing a stage, immediately press the green button again, or known as the submit button. Otherwise, a strike will issue and the module reset. What will happen is sometimes this bar will go empty and basically this bar becomes the same color as the background of the module. And you have to press the green button immediately, and then what it does, it fills the bar back up again and puts you at the same stage. So it puts you at the same current stage. So in this case, if paper or if plastic had a 0 bar right there, I'd press submit, it would still be on plastic. The thing is, you just have to press that submit button if the bar is empty after completing a stage. However, this cannot occur during stage 4, which is the leftover stage. So let's follow our rules. If the total sum of paper, plastic, metal is higher than 695, no. Go to rule 2. If the amount of metal exceeds 200, no. Let's go to rule 3. If the amount of metal is lower than the amount of paper present, no. Let's go to rule 4. If the amount of plastic is less than 300 and greater than 100, no, it's less than 100. So let's go to rule 5. If the amount of plastic is less than 100 and greater than 10, waste all the plastic. So here I would have waste plastic. Or I would have a plastic stage. Waste 91. And then I would put this as 0. Just to indicate, okay, I did the plastic stage. If the paper is less than 65, waste 1/3 the paper unless instruction 4 was true. Unfortunately, instruction 4 wasn't true, so, and there's nothing to do with paper, so no need to worry there. And if the amount of leftovers are less than 300. So let me talk about leftovers just a little bit. So any materials left after being modified by a rule become leftovers unless another rule refers to them again. Usually, it's not usually that case. But mostly after it's been modified by a rule and whatnot, anything that's left over after that rule has been effective goes to leftovers. And that's just it. So, after all that, this is our last instruction. We're going to submit our paper. However, the plastic, we have to waste 91 of it. So, to waste 91 of it, we have to convert this 91 into Roman numerals. So, I is 1, V is 5, the X is 10, and L is 50. So, and we usually go in order, can we actually subtract 50 from 91? Yes. So we're going to put an L and subtract 50 from it, which makes it 41. Can we subtract another 50? No. We can't subtract another 50. However, we can subtract 10 from it, and we can do it 4 times. So we're going to put X, 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 which leaves us with 1. Can we subtract 5 from it? No. Can we subtract 1 from it? Yes. And we can do it only once. So, this right here becomes how much we have to waste. Now, the thing about the Roman numerals of waste management is usually for 4 would be IV, which technically would be true, but in the case of this module, it would be false. Same thing with 9, which would be IX. Unfortunately, no. So they made it kind of a little bit simpler to make it like this. All you have to do is just subtract the most significant number. So we had 91. You have to subtract 50, and then we can subtract 4 tens and then subtract a 1 instead of trying to actually do the entire thing. So to submit this answer, we tell this diffuser, okay, L X X X. Okay, L 4 X's 1 I waste submit. So L X X X X I, and then we're gonna place the waste button, then submit. You see, all went well there. And then there's no metal, so we're gonna skip that. All right, one more module, and I'll cut the screen here. All right, 4 and 2. We got an unlit MSA, an unlit NSA, and 1 port plate with PS2, RJ, RCA. Serial number is Alpha Alpha 5, Echo Alpha 5. Very interesting serial number I got there. I keep getting the interesting ones, which are fun to do. So, paper. Is there an IND? No. Is there an SND indicator? No. Is there a parallel port? No. Morse code related modules? No. 0 batteries of bomb? No. Does the serial number contain any letters from Save My World? Yes. There's 3 A's and E. But there are absolutely no constants, so the operation pulls through. So we're going to do 200 paper. So our final operation is we have 200 paper. Next, let's do plastic. TRN indicator? No. FRK indicator? No. Empty port plate? No. FRQ indicator? No. So that's going to put as 0. And finally, metal. Bob indicator? No. MSA indicator? Yes, there is an MSA indicator. So we're going to add 92 to that. Any car indicator? No. Duplicate ports? No. SIG indicator? No. Forget-me-not? No. So these are our final values. Paper 200, misspell plastic, and metal 92. So let's go through each instruction. If the sum of paper plus and metal is higher than 695, 292 is entire, so let's go to rule 2. Otherwise, the amount of metal exceeds 200, no. So we're going to go to rule 3. Otherwise, the amount of metal is lower than the amount of paper present, which is correct. Yes, this statement is true, which means we are actually going to do this statement. And we're going to need a calculator for this, if we can. Calculator. So, we're going to recycle all the paper. 200. Okay. Recycle all. Allocate all plastic to leftovers. It's 0 so far. And then we have plastic 0. Do nothing with it. Metal. We're going to waste 1/4 of metal, which we're going to do this. So 92 times 0.25 or 25 or divided by 4, which gives us 23. So what becomes of the rest of the metal? Then we're going to add that to the leftovers. So we got 92 times 0.75, which is 3/4, which is 69 leftovers, and recycle half of the leftovers. So leftovers, recycle, we're going to recycle half of it. So our leftovers so far is at 69. We're going to divide it by 2. we have 34.5, but we're only going to do the integer part, so we're going to recycle 34 of it. And we're done, because we got our instructions for each one. And here's an important thing about this. So for metal, I know I got waste 23, and with 92 you can subtract minus 23, but you can't do that, unfortunately. What you have to do is take 92 and times it by the 0.5% left of it in order to get the amount of leftovers. Don't subtract the amount of metal you've wasted. Don't do that, because the answer would be wrong. You have to multiply it by the percentage amount of metal that you have left over. So that becomes a 0, this becomes a 0, this becomes a 0, because 34 is left and we don't do anything rest of the leftovers. So this is our final answer. Well, first we gotta turn it all into Roman numerals. So 200. I know 50, 50, 50, 50 equals to 200. So we're gonna cycle LLLL leftovers. So for 23, I can do 2 10s, which gives me 20, and then that leaves me with 3, so I can do 3 i's. So we're gonna waste that much and recycle 3 x's, which gives me 30, and then 4 1's, which gives me 4. So this is our answer. Okay, we're going to, for paper, LLLL recycle. Okay, press the submit. Okay, we're going to waste XXII. Waste. If you're not sure, you can press the reset button and resets the entire thing. So you can do XXII and then press the waste button and then press submit. And then we have the leftovers, which is a stage that doesn't always happen, but when it does happen, it means you do have leftovers. And then we're going to recycle 3x 4i. And that's a soft module. So now what I'm going to do is I'm going to cut the screen here. I'm going to give you all the edge work that you're going to need. So just for safe issues, there is no forget-me-nots and there's no Morse code type modules on here. So I got 3 and 2. I got a lit IND, an unlit TRN, and finally an empty port plate. Serial number Lima 82 Echo Echo 3. So start doing your calculations. And one thing to note, if you get a negative number, I know I forgot to say this, if you have a negative number, times it by -1 and just make it positive. That's all. I got my answer. So 3, 2, whole 1. So for what happened is the third rule applied. So I'm going to recycle 219 pieces of paper. All plastic is 0, metal is 0, and the leftovers I'm going to recycle half of 74, so that's going to be 32. Excuse me, 37. So for paper, I got 3, 4. I'm going to do an X, a 5, 2, 3, 4. Recycle, submit. Okay, plastic, submit, metal, submit, leftovers. X, X, X. V, I, recycle, submit. Ooh, what did I do wrong? I did something wrong. Well, now I got 1 strike issued. So the TRN indicator isn't going to do anything. So, I mean, I had a TRN indicator and I had an empty port plate. Unless there are an odd number of modules on the BOM. Okay, yes. I forgot the unless rule, which is something to easily overlook at. So, we'll do this final one together. I know you guys probably yelling at me like, Sean! Which probably the answer is probably 91. 91 divided by 2 is 45, and you would submit 45 as the leftovers. But now I gotta do this part again. So the recycled paper bit is gonna stay the same. The amount of metal that I have is gonna stay exactly the same. The plastic is gonna be different. So I have a TRN indicator, but exactly 1 strike has already been issued. So we're gonna add 0. So give me a second here. There's an empty port plate, but there's an odd number of modules. So that's also still 0. So for this one, I'm going to put 0 for plastic. So recycle all paper, allocate all plastic to leftovers, which is 0. Waste 1/4 metal. Metal is going to be still 0. So leftovers is going to be 0. So all I got to do is just recycle paper. Just, oh, okay, let me reset. I didn't. Done. Alright, I hope you enjoyed this tutorial. And until then, keep talking and don't explode.